Hello, friends. Welcome once again to this lecture. We have been discussing the bearing capacity of soils, the different terms associated with the same. What is ultimate bearing capacity? What is safe bearing capacity? What is net bearing capacity? What is allowable bearing capacity? And what are the general failures in soil which have to be considered before discussing the bearing capacity of soil? In today's lecture, we'll see the different criterions for finding out the bearing capacity of soils. What are the different factors on which the bearing capacity depends? And what are the different methods proposed by different scientists from time to time to find out the bearing capacity of soil? Now let's see what are the different criterions for finding out the different types of bearing capacity of soils. The first criteria of finding out the bearing capacity is that foundation we are talking about, the foundation which is located at appropriate depth. That means that it does not get affected by factors such as lateral expulsion of soil from beneath the foundation. It does not get affected from the seasonal volume changes, and it has no effect of the adjoining structures. The second criteria is the shear failure criteria, and the third one is the probable settlements. Shear failure and the settlement criteria are the basic criteria which we consider in order to find out the bearing capacity of soil. The minimum of the two has to be considered for finding out the safe bearing capacity of soil. Let's see, in shear failure criteria, we are looking at the soil which does not fail in shear and there is no plastic flow of the soil material beneath the foundation, and the lateral expulsion of the soil from beneath the footing is totally absent. There is no flow from underneath the soil. And there are no probable settlements, whether it is differential or the total settlements, and they are within the tolerable or acceptable limits. In other words, the anticipated settlement under the applied pressure on the foundation should not be detrimental to the stability of the structure. As I've told you earlier, the minimum value, the design value of the safe bearing capacity, obviously would be smaller of the two values obtained from these two criteria. Right? Now we'll see what are the different factors affecting the bearing capacity of soils. The first one is the nature of the soil and its physical and engineering properties. Now, as you know, soil may be cohesionless soils, it may be cohesive soils. When it is cohesionless soils, whether it is dense or loose, at what relative density it is, and when we talk about the cohesive soils, whether it is soft or whether it is hard, because we know that cohesion C and angle of internal friction phi, they are the most important factors affecting the shear strength of soil, which ultimately will affect the bearing capacity of soil. So what are the engineering properties and what is the nature of the soil is very important to know before finding out the bearing capacity of soil. Second, nature of the foundation and other details like size, shape, depth below the ground surface, and the rigidity of the structure. Now, all these factors, what is the length, what is the breadth, what is the shape, I mean, they all affect the bearing capacity. We'll see in the subsequent lectures when we discuss the different theories or the methods to find out the bearing capacity of soil as to how the size, shape, and the depth below which the foundation is situated affects the nature of foundation according to the Terzaghis theory or according to the IS codes. The size, the more is the size, more is the length or breadth of the foundation on the granular soils, the bearing capacity increases. And more is the depth, you will get more surcharge load and the bearing capacity improves. So, I mean, we should know the size, shape, and the depth of the foundation below the ground surface in order to know the bearing capacity of foundations. Total and differential settlements. This is also very important from the serviceability point of view. Uh, the differential settlements are very detrimental to the structural stability. Sometimes it's not the total settlements, but the differential settlements cause very heavy damage to the structures. So we need to understand and we need to know what are the allowable differential or the total settlements allowed in a particular region in order to find out the bearing capacity of the soil. The fourth one is the location of the groundwater table with relation to the level of the foundation. The fluctuation of the groundwater table does affect the bearing capacity of the soils because when it comes up, when the soil, when the groundwater is within the significant depth of the foundation, uh, it may lower, it may increase the bearing capacity of soil depending upon the conditions of the water table. We'll see when we'll study at large, we'll study in detail later what is the effect of the groundwater table. Uh, but definitely the fluctuation of the groundwater table affects the bearing capacity of soil. The initial stresses, if any, yes. We know that the soil may be normally consolidated. It may be over consolidated soils. So stress history, if we know, and if we try to find out the shear parameters, shear strength parameters, that is C and phi, we know that there are and there is overriding of the particles if it is over consolidated, and accordingly the value of C and phi will be different as compared to the normally consolidated soil. So these are the factors on which the bearing capacity of soil depends. Now let's look at the different methods for finding out the bearing capacity of soils. We use the various building codes. Each and every country has developed their own codes, keeping in view the soils in their different regions. Then there are analytical methods, plate bearing tests, and that is field tests, then penetration tests. We do have the model test and prototype test and the laboratory test. These are the tests which will be used and which will be discussed later for finding out the bearing capacity of soils. Now, when we talk about the analytical approach, based on the theory of elasticity, it's Schilcher's method, and then Rankin's method, Pocker's, and the Bell method, which is based on the classical earth pressure theory, and then Fellinius method, Prandtl, Terzaghis method, Meyerhoff's method, Scampton, Hansen, and Bala's method, which are basically based on the theory of plasticity. Plate and penetration tests, which are largely are the field tests, which are also invariably used in finding out the carrying capacity, load carrying capacity of the soil from the field perspective. Now, analytical method, Rankin was the first one to advance his theory on the bearing capacity of soil and suggested some ideas as to how we can find out the depth of foundation for different kind of soils. Of course, he used this method for the granular soils. He has not advanced this one for the C5 soil, and this we call it as that it is very approximate and conservative type of method, which was being advanced by Rankin. Now let's see how Rankin suggested his method in order to find out the bearing capacity of soil. Now this Rankin method is based on it makes use of the principal stresses and the limit equilibrium method, and this you can very well see. This is the foundation, which is having the depth df, and this is the load acting on the base of the foundation. Limit equilibrium conditions means that this soil is sufficient enough, the bearing capacity, the sustaining power is just sufficient enough to take the loads which are coming from the top, and we are going to consider two particles, one immediately below the base of the foundation, and the second one is outside this vertical boundary, which is outside the base of the foundation. Now we need to analyze this particle 1 and the soil element part 2, which is outside the foundation. Now, when we study this element 1, which is just beneath the foundation, at the base of the foundation, the applied pressure, that is Q ultimate, is the major principal stress, because we are going to make use of the principal stresses, the concept of the principal stresses here while analyzing the soil elements beneath and just away from the foundation. Under its influence, the soil adjacent to the particle tends or is pushed out. That is, it's a active condition. They are the creative active condition. That means the pressure from the from the top of the foundation is on vertical side, and you get push from the horizontal side. The soil element will be under the different kind of forces you can see here, and this push will make the active conditions. And if we want to find out what is the total pressure, what is sigma on the, what is the active pressure, that is, let us represent as sigma from the relationship of the major principal stresses, where we have found out sigma 1 is equal to sigma 3 tan square alpha plus 2c tan alpha. It was for C5 soils, and when we don't consider C, it simply gets reduced to sigma 1 is equal to sigma 3 tan square alpha, where sigma 1 is the major principal stress and sigma 3 is the minor principal stress, based on the same principle. And when we apply the limit equilibrium conditions, your sigma will be equal to Q ultimate multiplied by Ka. Now Ka is the active earth pressure coefficient. This is the load. This is the active earth, pressure being developed in the horizontal direction. So Q ultimate multiplied by Ka, and Ka, as we know from the earth pressure theories, that it is equal to 1 minus sine phi upon 1 plus sine phi. So we get the equation 1, which says that sigma will be equal to Q ultimate multiplied by 1 minus sine phi upon 1 plus sine phi. Now let's see, let's try to analyze the element 2 here. Now in element 2, which is just outside the footing at the base level of the foundation, the tendency of this soil adjacent to the element is to compress. That means the tendency is to create the passive conditions. The pressure sigma on the vertical faces of the element will thus be it will have the passive resistance, and this will thus be major principal stress and the corresponding minor principal stresses. Now, here, the vertical stress is going to be the minor principal stress, this one, and this passive force, which is from, which is being sustained by the second element, which is just outside, is going to be the major principal stress. Now, when we apply the same concept of the relation between the major and minor principal stresses, that means sigma 1 major principal stress will be equal to minor principal stress tan square alpha, and you apply the same concept here. Sigma will be equal to Q times Kp because the conditions are passive here. So you get gamma dF into Kp, and you get equation 2. Now, when you try to put the value of gamma, which you obtain from the equation 1, you get reduced to, Q ultimate is equal to gamma dF into 1 plus sine phi upon 1 minus sine phi whole square. Now, this gives the bearing capacity of the foundation or the footing. Now, as you will see, it does not appear to take into account the size of the footing. That means, according to the Rankine's theory, the ultimate bearing capacity of the soil is totally independent of the length or width of the foundation, but in nature it doesn't happen anymore. So because it is a very approximate kind of method, just to understand as to how the theory of finding out the bearing capacity of soils, they have been advanced, and the different particles, they were being analyzed, in order to find out the different bearing capacity of soils. So according to Rankine's theory, the minimum depth of foundation required is can be calculated as Q upon gamma into 1 minus sine phi upon 1 plus sine phi whole square. Now, barring the limitations, this was the basic method. In the further lectures, we'll analyze how this theory of Rankine was being taken into consideration for the modifications for C5 soils in order to find out the bearing capacity based on different parameters. We'll see how Terzaghi has done it, how the different building codes have come up today for finding out the bearing capacity of the C5 soils. Till then, thank you very much.